Hello learners and welcome to your Natural Sciences lesson. So today we're going to be doing practice questions and application questions that are based on a series in a parallel circuit. So to begin with our practice questions, so we have the first question that says, how are the light bulbs in this circuit connected? So we need to remember that there are two types of connections. The circuit and the light bulbs can either be connected in series or connected in parallel. Now the main difference between those two connections is the way in which the current flows in a series circuit through the light bulbs and also in a parallel circuit through the light bulbs. So we know that our current is going to be moving from the negative terminal to the positive terminal, going through the wires, and once it gets to this point, it has to divide. Now the moment your current divides into the two resistors, remember that we are using our resistors as our light bulbs in this case. So because our current divides when it gets to this point so that it can pass through these two resistors, then we can say that our connection and these light bulbs are connected in parallel, because there's more than one pathway for the current to follow as it is moving from negative terminal to the positive terminal and then back to again to the negative terminal in the battery. Because after having passed through this light bulb and also this one here, when that current gets to this point, they will add up together to be equals to the total current of the entire circuit and then go back to the battery. Remember, at this point it divides proportionally. That means the resistance, or the resistor rather, with a higher resistance will receive less current. So if these two light bulbs were identical, then they would receive the same amount of current through them. However, if the two light bulbs were connected in series, they would be connected one after the other. That would mean there would only be one pathway for the current to follow. So if this is your battery, we would have our first resistor here, which is our first light bulb, and then our second one there. They are following each other one after the other. As you can see, if your current was to leave the battery, going through the wires, all of that current will be passing through the first resistor, which is our first light bulb, and then again passing through the second light bulb, which is our resistor again. So the total current passing through the first light bulb will be equal to the total current passing through the second light bulb. Whereas in parallel, the current, when it gets to this point, it divides. In series, the current doesn't divide. The current is going to be equal at whatever point you measure it from, whereas in parallel, the current depends on where you are measuring it from. If you are measuring it before it divides, it is going to be greater than the current measured at any of these two resistors that you have here in parallel. So when looking at this question, our answer is going to be C. So question 2 now is asking us, what can you say about the voltages in a parallel circuit? So the options are, it is the same across each component. B, there is no voltage in a parallel circuit. C, it is the same across each branch as the supply voltage. And then option D, when you add the voltage across each component together, it is equal to the supply voltage. So now we need to go back and rethink about the parallel connection or a parallel circuit in this case. Remember, in parallel, we have, in parallel and series, we have things that you need to be talking about. We need to talk about the current. We also need to talk about the voltage, and then lastly, we need to talk about the resistance. This is coming from the resistors that we're adding in our circuit, being the light bulbs in this case. So in a parallel circuit, we know that the current divides and the resistance is going to be decreasing. So the more resistors we add in parallel, the resistance of the circuit decreases, but then the current is going to divide. And remember, when it divides proportionally. The resistance, or the resistor with the highest resistance, will receive less current. So now, what about then the voltage? So the voltage in a parallel circuit, it is going to remain the same throughout. However, in a series connection, this now becomes different. We are saying that in series, the current remains the same, the voltage divides, whereas the resistance is going to increase. Whereas in parallel, the resistance decreases, the voltage remains the same and the current is going to divide. So what happens in parallel to the current happens in series with the voltage. And what happens in series with the voltage happens in parallel with the current. So now our answer for this question is going to be A. It is going to be the same across each component because the voltage in parallel remains the same, whereas the current divides and the resistance is going to decrease. Now moving on to the next question. What can you then say about the current in a parallel circuit? Remember, in a parallel circuit, the current divides, it splits into the multiple ways that we have in all of the pathways that we have in a circuit. So we are saying, starting from D, the supply current is equal to the current in each branch added together. It is the same in each component. Remember, in parallel, the current is going to divide according to the resistance of the resistor. The greater the resistance, the lower the current passing through. Remember, current will always look for the path that has the least resistance. The lower the resistance, the higher the current passing through that particular resistor. So it is not going to be the same in each component. It is not going to be the same everywhere. However, the supply current is going to be equal to the current in each branch added together. So when we add all of the currents passing through each of the resistor, it is going to be equal to the total current of the entire circuit. So our answer is D. Next one. What happens when one light goes out or removed in a parallel circuit? So remember, we can think of our homes. We have a 3-room house, a 4-room house, a 5-room house. If one of the light bulbs goes out or is removed, what happens to the other light bulbs in all the other rooms? Nothing happens. All the lights go out. Only that light goes out and half of the light go out. Remember, if you have a 5-room house, if one light bulb in one of the rooms goes out, all the other light bulbs can still work. That's the advantage of using a parallel circuit. So therefore, our answer here is C, that only that one light bulb is going to go out. The other ones will still be functioning. Now, we now need to complete this statement still under practice questions. Question says, if you increase the resistance in a parallel circuit, what then happens? So remember, if we have a parallel circuit and you add more resistors in that particular circuit, we are actually decreasing the total resistance of the circuit. Now remember the relationship between the resistance and current, that they are inversely proportional. When one decreases, the other one must increase. So by adding resistors in parallel, we are decreasing the resistance. And by decreasing the resistance, the current strength is going to increase. So therefore, looking at our options that are given here, the current will also increase, the current will decrease, the voltage will increase, or the voltage will decrease. Remember the relationship, resistance decreases and the current is going to increase. If we increase resistance in a parallel circuit, we are going to be decreasing the current. So if the resistance in a parallel circuit is increased, then the current is going to decrease. So our answer is B. Next question. Electric current is measured in. So current, the electric current, what do we use, or what is the electric current measured in? Is it measured in amperes? Is it measured in watts? Is it measured in meters? Or is it measured in centimeters? We know that the last two, those ones, they are used to measure distance, or they are used to measure length. So they will never be used to measure current. Now, power is measured in watts. So watts is a unit of measure for power, and then therefore that means our electric current is measured in amperes, which is option A. So with all of that said, we're just going to quickly go for a short break, and I will see you just after this.